Today we're going to look at integrating curves given in a parametric form. That's where two equations are connected by a common variable, usually the letter t. So the integral of y dx dt is equal to the integral of y times dx dt by dt. It's easier to understand with an example. So we're going to look at this one. Find the area bound between the curve with parametric equations x equals t squared and y equals t plus 1, the x-axis, and the lines x equals 0 and x equals 3. That's a fancy way of saying find the area under the curve between 0 and 3 along the x-axis. To do that, we're going to do it in 3 steps. We're going to find dx dt first. If x is t squared, then dx dt is equal to 2t. The second step we're going to look at is changing the limits. Why do we need to do that? The limits at the minute are in terms of x. In order to successfully integrate this, we need to change them to t. Now, if x is equal to t squared, it should be easy enough to change 0 and 3 into t. 0 is t squared, so 0 is t. There's our first limit. Didn't really change at all. X is 0, t is 0. If x is 3, our limit does change a little bit. The square root of 3 is root 3. So we're going to integrate between 0 and root 3. Again, we're changing everything in terms of t. Now, our integral itself, to integrate y with respect to x, we use our formula. We know the integral of y with respect to x is equal to the integral of y times dx dt. So I'm just writing the formula down to remind myself of that. At this stage, I'm going to swap out everything for what I know. I know I'm integrating between two limits. I know my y is that. I know my dx dt is 2t. So I'm going to integrate between t plus 1 times 2t. That's y dx dt. And I'm using my limits, root 3 and 0. Biggest one on the top, smallest one on the bottom. After that, it's very straightforward. Multiply your brackets out. T plus 1 times 2t should be 2t squared plus 2t. And then integrate with respect to t. And to integrate, follow your basic steps. Add 1 to the power and divide by the new power. So we should have 2 over 3 t cubed plus t squared between root 3 and 0. Very straightforward again. Your next step is to simply plug in your limits, root 3 and 0. Be careful with your algebra. So 2 over 3 times root 3 cubed plus root 3 squared. Take away 0, essentially, is what you're going to have. Do feel free to use a calculator to check this if you like. Give your answer in exact form. Do not round off to a certain amount of decimal places unless you're specifically told to do so. Leave your answer as a square root. It should be 2 root 3 plus 3. You can check it on your calculator if you like. But that is your exact answer. Okay, we're going to try this again with another example. A very similar example. The only difference between this one and the last one is that this one has a little bit of trigonometry involved. We're going to find essentially this yellow area given by the curve defined as x equals 4t plus pi and y equals 1 plus sine of t between the limits 5 pi to pi. As before, we're going to follow the exact same steps. Our first step is to find dx dt. And if you differentiate 4t plus pi, you get 4. We're going to change our limits from x to t. Now our equation is x equals 4t plus pi. If we plug both our limits in one at a time, work through it nice and slow, get our value for t. So if x is pi, stick that in first. Pi is 4t plus pi, subtract a pi from both sides. So 0 is 4t, and then divide by 4. Your first limit is 0. Do it with 5 pi as well. 5 pi equals 4t plus pi. Subtract pi from both sides, so 4 pi equals 4t, and divide by 4. So 1 pi is t. And there's our limits, 0 and pi. And our third step, as before, is to integrate. The first thing I'm going to do is to write down the formula as before, just so I know I'm putting things in the right place. My formula is the integral of y times dx dt by dt. My second step is to plug everything into the correct place. So my limits were pi and 0. And I'm multiplying 4 by 1 plus sine of t dt. From there, I'm just going to integrate it. I'm going to take out a 4 though first. Just because I find 1 plus sign easier to integrate without the 4 involved. You do not have to do this step. You can just multiply by 4 first if you like. It doesn't make a shred of difference to your answer. I just try to make it simple before I integrate. So if I integrate 1 plus sine of t, I get t minus cos of t. If you integrate plus sine, you get minus cos. I'm going to keep my 4 outside until I'm finished, essentially. So I'm going to have 4 multiplied by my limits plugged into the correct place. In your exam, please show the examiner this step. There is always a mark for plugging limits into the correct place. Assuming you've got the integration right to this point, of course. And if you're using a calculator, make sure it's on radians mode for this. Anytime you do trigonometry in pi's, you must use radians on your calculator. So cos of pi is 1, minus cos of pi is plus 1, I should say. And cos of 0 is also 1. And then simply simplify it. So you should have 4 times pi plus 2, or if you multiply your brackets out, 4 pi plus 8. This is your exact area. I am not writing it as a decimal. I will never write it as a decimal unless specifically asked to do so. For our last example, we're going to integrate the curve defined parametrically with an unknown power. This time we've got y equals 2 to the power of t minus 1. It's basically the same as before, except we've got an unknown power we'll have to integrate. So we're going to find this yellow shaded area between minus 1 to 1 under the curve defined as x equals 1 minus a half t plus y equals 2 to the t minus 1. As before, find the x dt first. It should be minus a half. That's very straightforward. Again, as before, your second step is to find your limits in terms of t. So we've got x is minus 1 and 1. Our equation is x equals 1 minus a half t. I take these equations nice and slow and do a step at a time so I don't get lost. So I'm setting minus 1, my first limit, in for x. I'm going to subtract 1 from both sides to get minus 2 equals minus a half t, and then multiply across, and I have 4 equals t. Be very careful with your minus signs. Similar for the 1. I should have 1 equals 1 minus a half t. The answer should be obvious, but I'm doing it nice and slow anyway. Take away 1 from both sides, multiply across by minus a half, and you should have 0 equals t. I should have said divide by minus a half there. But regardless, your limits are 4 and 0. Big limit goes on top. So I'm integrating between 4 and 0 my y dx dt dt. Always the greater number on top. And if I plug in my values for y and dx dt, I'm going to have minus a half multiplied by 2 to the t minus 1. Now this time I would certainly advise taking the minus a half out and ignoring it until you've finished your question. It'd be a lot easier if you do that. Move the minus a half on the outside. So your question is minus a half times the integral of between 4 and 0, 2 to the t minus 1 dt. And then integrate what's in there. So I'm going to have minus a half multiplied by my answer. If you integrate 2 to the power of t, you're going to end up with 2 to the power of t divided by the log of 2. And integrate minus 1, you should get minus t. Exactly as before, always the same with these questions. Plug in your limits, go nice and slow, take your time. Do not rush them or try to skip steps. You'll probably get lost if you do that. So I'm writing out my question again. I'm sticking in 4 and 0. So 2 to the power of 4 over log 2, take away 4, subtract 2 to the power of 0 divided by log 2 minus 0. And that's all multiplied by minus a half. Again, I'm ignoring the minus a half until I'm finished. Simplify what's in there. 2 to the power of 4 is 16. So I've got 16 over the log of 2. Take away 4. And 2 to the power of 0 is 1. So I've got 1 over the log of 2. And of course 0 is 0. I can ignore that. So 16 over log of 2. Take away 1 over log of 2. What does that make? Well, if you know what 16 take away 1 is, you should be able to work it out. 16 take away 1 is, of course, 15. So 15 over the log of 2. Subtract 4 inside that bracket. Now, deal with the minus a half. Multiply through by it. So you should have minus 15 over 2 log 2 plus 2. And this is my exact area. Again, do not write it as a decimal unless specifically told to do so. Thanks for watching. Please make sure you click like and subscribe.